So we have two ways to solve equations with logs in them. The first way deals with when some of the terms are inside a log, but some aren't. So generally that means you have logs on one side of the equation, but not the others. For these types of problems, this one's already condensed for us. We just want to switch from logarithmic form into exponential form. And this is what we already did yesterday with logs, or 2 days ago with logs, the first day. Same idea, it's just going to be mixed in. So here we have a log base 2 is equal to 3, so if we just switch this around, remember base of the log is the base of your exponent. Bring it around to the other side, so we have 2 cubed, then bring it up and in, equals x cubed minus 19. So we just want to switch from logarithmic to exponential form. Now we can solve it like any normal equation. 2 cubed is 8, so x cubed minus 19, add our 19 to the other side, so we get 27 equals 2 cubed. Take a cube root, and we get x equals 3. And that's it. So now switching forms can work for logs of any base, including natural logs. The main thing you just need to remember is that natural log means log with a base of e. So here, we have a choice. We can bring the 7 up onto the x, but really what will make this easier, we can just divide the 7 out first. So you cannot switch forms until all the logs are combined and there are no coefficients left on the logs. So we have to get rid of that 7 first. Now we have natural log of x equals 4. Now we can just switch our forms around. So natural log is a log with a base of e. So we have base of e, bring it around, raised to the 4th power, equals x. There's our answer. So now for this last one, the key to be able to switch forms is you have to have all the logs combined to be a single logarithm. So here's where the properties come into play. Before we can switch these around, because we notice we have 2 terms with a log, we have a third term that is not a part of a log. So that's how we know we'll be using the method of switching forms. But in order to do that, our first step is combining these. So we have log base 2. Remember, whenever something is being added, when you combine it, it turns into multiplication. So we have 3x minus 7 times x minus 4, and that whole thing equals 3. Now we can switch our forms. Base of the log is the base of the exponent. 2 cubed equals the whole inside. Now I'm just going to go ahead and multiply this out because we're going to need to anyways. So 3x squared minus 12x minus another 7x would be a minus 19x plus 28. This is a quadratic, so now we just need to set it equal to 0. 2 cubed is 8. And then factor. So we have 0 equals 3x squared minus 19x plus 20. Go ahead and factor this. We know that in the parentheses for it to multiply to be 3x squared, we need a 3x and an x. Since it multiplies to be a positive but adds to be a negative, we know we're going to have 2 subtractions in there. So now we just need factors that multiply 20. When it multiplies out, it adds to negative 19. And those factors would be a 5 in the spot that'll multiply with 3, a 4 in the other spot. And when you're guessing and checking, a way to check this, 5 times 3 would give us 15. 4 times x would give us 4. Negative 15x minus 4x is how we would get that negative 19x. Okay, last step. Solve each of these. So this would be x equals 4/3. This side would be x equals 5. Now, the key with these when we combine our logs is we need to go back and check our answers in the original equation. This is imperative because you cannot take a log of a negative number. And when we combine things, that idea could get lost in the solving process. So we need to take 5, plug it back in, take 4/3, plug it back in, make sure neither of these will make the equations negative. So let's start with 4/3. If we come up here, we do 3 times 4/3 minus 7. Those 3 would cancel. So we would end up with 4 minus 7 up there, which is a negative 3. It makes that log negative, therefore it is not a viable answer to this solution. It doesn't matter if it makes every log negative or just one. The second you end up with a negative log, that answer can't work anymore. So now for the next one with 5, if we plug a 5 in this first one, 3 times 5 is 15, minus 7 is 8. That one's good. 5 minus 4 is 1. That one's okay. So 5 is our only answer to that problem.